All right, what we'll be discussing today is solar panels in parallel and series. We have two separate strings of 12 modules. Being in series means plus to minus, plus to minus. At the back of each of these solar panels is a plus terminal and a negative terminal, positive terminal, negative terminal. So as you connect them, positive to minus, that will put them in series, which adds voltage. So you've got two separate strings strung up plus to minus through the 12 panels in each of them. When you take that and put them into parallel where you attach plus to plus, minus to minus, that will add the current. So essentially you'll end up getting the voltage you're looking for and the current that you're trying to accommodate. With each different type of string setup, you can do the same thing so that you get whatever current and voltage your inverter needs to accommodate. So if you look at how voltage adds in series and current adds in parallel, you can get whatever configuration you're looking for. Sometimes, like an inverter this size, you'll end up with a 5,000 watt inverter based on the amount of current and voltage that you get. When you multiply the number of the rating of the power on each of the panels times the number of modules, which is 24, you'll end up with 4,800 watts. When you put them into strings and series, you'll also end up with the same amount of rating. So you'll get a 15.4 amps from adding in parallel. You'll get your current to add. And then your voltage will be 12 modules times the 26.3 rated voltage from each module. So basically what you end up doing is you've got V times I is equal to P. So you've got the power is equal to the voltage times the current, which adds in series and parallel. So those are the kinds of things you want to be able to understand when you're figuring out what your system size is going to be, how you're going to configure it, and what your inverter size will end up being. Probably in our next objective we'll end up going with this type of current rating and the type of voltage rating as it goes into the inverter and out the other side. What kind of safety do we have to have in the wire sizing? So we'll talk about conductor sizing, how to safely accommodate those loads, the load being the inverter from the power source, which are the panels. So as we go through this process, we'll start getting a little bit more into the safety end of how do you apply these numbers to electrical code. All right, for now, two strings of 12 modules. 12 modules add up, add the voltage, so you end up with 316 volts. Two strings added up in parallel, give you 15.4 amps. This times this will end up, it's about 4,860 watts, which depending upon how you rate each of your ratings, that should end up equal to that. So we're a little bit over, but you also have to accommodate the temperature differences and things like that as we go forward. So thanks. So